and welcome to Unit 5, Lesson 4. In this lesson, we'll continue our study of problems that involve calculating with percents. But in this first lesson, we're going to focus on a particular kind of problem where we're asked to find the percent change. So it could be a percent of increase or it could be a percent of decrease. It just depends on whether the original amount rose or did it fall. So when we look at percent of change, what we're focusing on is a comparison of the original value and the new value, but we're specifically looking at that change as a percent of what it was first. So you want to think, okay, well, how much did it change? So how much did it go up or down, which you would figure out by subtracting. Always calculate change by subtracting. And then we want to think about that amount as a percent of the original amount. That then allows us to determine whether or not that change was significant or was it just a minor change. So here's what we're doing when we calculate percent change. We're taking the difference between the old and the new. So we're just subtracting to determine how much was the change. Then we're dividing that by what was it first? What was the old amount, or what was it first? And then, since we want our answer as a percent, we'll multiply by 100 or simply move the decimal to the right. So in this first example, it says in 1950, you could purchase a movie ticket for 46 cents. Today, the average cost of a movie ticket is $7.50. What is the percent increase in the cost of a movie ticket? So before we can talk about the percent increase, we need to see by how much did it increase. So to do that, we'll subtract. So we'll do $7.50 minus 46 cents. And then we'll divide that by what it was first. What was the original amount? So the original amount was that 46 cents. So we'll be dividing by 46 cents, and then we'll multiply by 100 or move the decimal 2 places to the right. So let's first subtract. So $7.50 minus 46 cents. We'll have to borrow. So that's a difference of $7.04. So what that means is we have $7.04 divided by what it was first, which was 46 cents. So let's go ahead and set up that division problem. $7.04 divided by 46 cents. And we know that when we divide with decimals, we can't have a decimal outside the house. So we'll move that decimal 2 to the right, which means we'll then come in the house and move that decimal 2 to the right as well. And then we'll place our decimal correctly on the roof. Now 46 won't go into 7. So we think, okay, how many times will 46 go into 70? We'll just go once. And 1 times 46 is 46. Now we'll subtract. And then we'll drop that 4. So now we're looking at 46 into 244. Let's look at maybe 5 times. 5 times 6 is 30. 5 times 4 is 20, plus 3 is 23. Okay, so we'll say 5 times. That gave us 230. And now we'll subtract again. Drop a 0. So now 46 into 140. Let's look at 3 times. 3 times 6 is 18. 3 times 4 is 12, plus 1 is 13. So 3 times. And subtract up a 0. 46 will go into 20 0 times. It hasn't come out evenly yet, but as a decimal, we have about 15.30. And then, remember, we'll have to move the decimal 2 to the right. So we ended up with 15.30. Now we have to do this times 100 part. So we'll take that decimal and move it to the right, which gives us 1,530%. You might think, well, wait, that's way too big. That can't possibly be right. But remember, if the cost of something doubles, that's 100% increase right there. And so we went from 46 cents to $7.50. So this far more than doubled. So it makes sense that we had this really large percent increase. Okay, next one. As soon as a new car is purchased and driven away from the dealership, it begins to lose its value. Jose bought a 2010 Plymouth Neon for $8,500. 1 year later, the value of the car was $7,250. What was the percent of decrease in the value of the car? So percent decrease. So remember, we want the change or the difference between the two divided by what it was first, and then times 100 or decimal 2 to the right. So to get the change, we'll have to look at 8,500 minus 7,250 divided by what it was first. Well, first it was 8,500. So in this case, the bigger number came first, and then times 100. So let's subtract. So 8,500 minus 7,250. Is 1,250. So we have 1,250 divided by 8,500 and then times 100. So let's do 1,250 divided by 8,500. So 1,250 divided by 8,500. Okay, well, 8,500 won't go into 1,250. So I'll raise a decimal, drop a 0. So now I'm thinking 8,500 into 12,500. I'll only go one time. And that would be 8,500. We'll subtract. And we get 4,000. Let's drop another 0. So now we have 8,500 into 40,000. Let's try 4. 4 times 5 is 20. 4 times 8 is 32. Plus 2 is 34. So it'll go in 4 times. That was 34,000. And we can drop another 0. So now we're looking at 8,500 into 60,000. So let's look at 8,500. Let's try times 7. That's 59,500. Okay. So it hasn't come out evenly yet, but we've gotten ourselves close enough that we can get a pretty good estimate here. So as a decimal, we get about 0.147. So 0.147. But then we have to remember we have that times 100 to turn it into a percent. So we're going to move that decimal 2 to the right. So we end up with about 14.7%. We could even say about 15%. So the cost of the car decreased by about 15%. In other words, that difference, 1,250, is about 15% of the original cost of the car. Last example. A recent advance in automation technology has made it possible for a cereal manufacturer to produce 1,800 boxes of cereal per hour instead of 1,200 boxes per hour. What is the percent of increase in the production rate? So again, percent increase or percent decrease doesn't matter. We still do the change in the values or the difference in the values divided by what it was first and then times 100. So in this case, this will be 1,800 minus 1,200 divided by what it was first. So it said that the change in the technology made it possible for them to produce 1,800 instead of 1,200. So the 1,200 is what came first. But to be careful there, because 1,200 isn't what was written first in the problem. When we say first, we mean in chronological order. Thinking about time, what came first? Well, the 1,200 came first because this advance in automation technology is what led them to be able to produce 1,800. So it was 1,200 that came first, and then times 100. So 1,800 minus 1,200 is 600 divided by what it was first, and then times 100. So 600 divided by 1,200, you might already be recognizing that as a half, but let's just make sure. So we had, 600 divided by 1,200. And of course, 1,200 won't go into 600, so we'll raise a decimal, drop a 0. And now we have 1,200 into 6,000. We'll do that times 5, which is 6,000. So this one came out evenly. So we get 0.5. And then times 100, which means we have to move that decimal 2 to the right and fill that hole with a 0. So this is a 50% increase. In other words, if you take half of what it originally was, so half of 1,200, which would be 600, and then add that to the 1,200, you would get that new amount of 1,800. And that is it for Unit 5, Lesson 4, percent of change. Again, the key here is to remember that whether you're finding percent increase or percent decrease, doesn't matter. Either way, you're going to do the difference between the two, divided by what it was first, and then move that decimal 2 to the right, or multiply times 100. That's it for percent of change. If you would like to see some additional examples, I'd be happy to go over those with you. If you're ready for the skill check to be open, I can do that. Thanks and have a great day.